Hi, in this tutorial, we are going to create a machine learning model that detects fake news in Twitter using Python and machine learning. The pipeline of this project is the following. First, we will preprocess the data by deleting the numbers, special characters. We will delete the stop words. We will stem the words. The second step is we will apply NLP techniques like bag of words and TF-IDF. The third step, we will apply classification algorithms. The three algorithms we will use in this example are logistic regression, linear SVC, and passive-aggressive classifier, which is an online learning algorithm. And the last step we will evaluate the algorithms by using the accuracy metric. First, we will import the necessary libraries and packages. To clean the data, we will use preprocessing package from scikit-learn, stop words from NLTK corpus, and Porter stammer from NLTK, and also the algorithms we will use, linear SVC, passive-aggressive classifier, and logistic regression. And for the evaluation, we will need a metrics package from scikit-learn. The data used in this example is a dataset of real and fake tweets scrubbed from Twitter. We will load the training and test set using readCSV function. Then later we will explore the first lines of those datasets to analyze this data. Also, we can explore the first lines of the test dataset. And let's see the shape of both those datasets. Also, we need to check that our dataset is balanced and has no missing values. Before moving any deeper into the project, we need to spend some time understanding the dataset. That's why we will read some examples of real and fake tweets to have an idea. Now we will move to the pre-processing step in our project. The first step in our pre-processing phase is to transform the categorical labels into numbers using label encoder function. We will fit and transform both of the datasets. We will create a function that will clean the data using regex. The first line will return only the characters from A to Z, uppercase and lowercase. The second line will lowercase all the strings, and then split will turn those strings into a list. After this, we will delete all the stop words and we will stem all the word in the list. And the function will return a string and not a list because we will have an error when using bag of words and TF-IDF later. We will apply this function on both the training and the test datasets. And here is an example of the preprocessed data. Now we will split the datasets into features, which is X, and an outcome, which is Y, on both the training dataset and the test dataset. Let's explain bag of words technique. Bag of words is a technique used to transform those sentences and words into a numerical representation. Those numbers represent the occurrences of those words within those sentences. For example, the word she occurs one time in the first sentence, one time in the second sentence, and 0 time in the last sentence. The same rule goes for the other words. To apply bag of words, we will use the function countervectorizer with two specific parameters, max features and n-gram range. The n-gram range works as the following. We will have 1 to 2 to 3 combinations. For example, if we have the sentence "the course was long," the first word is the second combination is the course, the third combination is the course was. Then we will have the second word course, then course was, and the third combination is course was long. So we will have a unigram, bigram, and trigram combinations of words. We will fit this function to our training dataset, and then we will transform our test dataset. Also, we will define a function to plot the confusion matrix. You can find this specific function code on the scikit-learn website. In this project, we will train 3 models: logistic regression, linear SVC, and passive-aggressive classifier, and we will evaluate them using the accuracy matrix. We can also plot the confusion matrix for each algorithm. This is a specific example of the linear SVC confusion matrix. Now, instead of applying the technique bag of words, we will apply another technique called TF-IDF. TF-IDF stands for Term Frequency Inverse Document Frequency, and it's a measure used in machine learning and information retrieval that quantify the importance of a string representation in a document amongst a collection of documents. In our example, we will have the frequency of a word within a tweet multiplied by the frequency of the word across all the tweets. In this example, we will use TF-IDF vectorizer from the scikit-learn library, and after this we will repeat the same previous steps. After applying TF-IDF, we will split the data set into training and validation sets, and then we will train the same 3 models: logistic regression, linear SVC, and passive-aggressive classifier. We can test our models on a new test dataset and get the accuracy of each one. After comparing between all the results, after applying bag of words, TF-IDF, and the 3 algorithms, we conclude that linear SVC and applying the technique TF-IDF gave the best performance in this case. You can find the code source of this project in the description. If you have a question or a suggestion, you can leave it in the comments section below.